Okay, I promised that I was going to be going through all the math for all you geeks out there. Please don't take offense, I'm a geek too, okay? So what we're going to be going through here is just seeing exactly how all this math adds up. So what I've done is I've brought up a example file. It's example number 8, I believe. It's called tritone. It's just 3 sine waves, each at different specified levels. The reason I'm using a sine wave is it's a very accurate wave. It's not bouncing around or doing anything like that. I've got it through a compressor right now, which is set at default. It's also bypassed, and then I've followed that along with a level meter that is going to be looking at the peak levels of these guys here. The reason I'm setting this up to peak, and in fact I'm going to do the same over in my compressor so that its detection can be set up to be looking at peak levels, is it's a little bit more of a clinical, we'll get far more accurate numbers if we're looking at all this math. So this is set to peak, the level meter is set to peak, this is bypassed right now, so we're just looking at the exact levels that are coming off of this track, and we'll start it at the top. Minus 20. Minus 10 and 0. So you can see I've set them up there at specific levels so that we can have some fun with our compressor. So I'm going to take the bypass off. So now this track will be going through this compressor, and we'll be able to see what's going on. Now the first part is set at minus 20. So therefore, if everything's set correctly, if this is set at peak and I set this to minus 20, then we should have 0 gain reduction. That makes sense, right? If this is set to minus 20 and this is exactly minus 20, then we know, we've learned this a million times, that only the stuff above that threshold will get compressed. So when I press play, I should see 0 gain reduction there, right? Nah, I'm seeing some gain reduction. Why is that? Can anybody kind of have an idea of what's going on? Maybe there's a few astute ones can see exactly what's going on. It's the knee. The knee is graduating into this threshold. So a soft knee will start that compression a little below that threshold. If we set this to a hard knee, right here, then we should see, beautiful, we see 0 gain reduction here. If we were to bump this down just a tiny bit, yeah, we start seeing it. Okay, so let's set this back to 0 there. In fact, I'm going to set up the gain reduction to be, the makeup gain to be 0. The knee is going to be that way. We're going to start off with a 2-to-1 ratio, setting at peak. Okay, let's start having some fun. What we're going to do is go between this portion and this portion. Remember, this is minus 20 and this is minus 10. So when the playback head crosses across here, how much more level is going to be coming into this compressor? There's going to be 10 dB more, right? Right now with the threshold at minus 20, nothing's happening here, but as soon as it hits this, we're going to be 10 dB over this threshold. And with a ratio of 2-to-1, in other words, 10 dB is coming in over this threshold, 2-to-1, how much gain reduction should we be seeing here? Well, let's test it. No gain reduction, and get ready. There you go, 5. And for extra credit, what's going to happen when we go up here? Another 10 dB. How much gain reduction is going to be? Check it out. Exactly, as you jump up 10 dB with a 2-to-1 ratio, the first step up here is only going to let 5 dB come through. There will be a gain reduction of 5 dB. And then when it jumps up another 10 dB, it's going to be halving that again. So there's a 20 range between here, which is the threshold, and here. So therefore, only half of that will be coming in, half of that 20 degree span, that 20 dB span is 10 dB. Let's try, let's say we're 5-to-1. What are we going to see here? Okay, the first one There's a 10 dB difference and a 5:1 ratio. In other words, 10 dBs coming in, 10 more dB is coming in over that threshold, and it's going to be compressed 5:1. What is that going to be? Think about it. Okay, let's see. That's right, 8 dB reduction, because with a 10 dB span there, and we're reducing it 5:1, then that's only going to give us 2 dB out. So 10 minus 2 gives us our 8 dB reduction. Let's see how it looks over here on the third one. See if you can guess the outcome. Yep, about 16 dB. It's only letting 4 dB out. It's a 20 dB span, 5:1, right? So it's only going to let through 4 dB, and 20 minus 4 is about 16 dB. So I hope you got those ones right. If you like, pop this into your own DAW and start messing around with the compressors and see if you can guess all of that gain reduction. By the way, in order for this to work, you'll probably need to have peak detection on to get these kind of clinical numbers.